everybody. My name is Chiara Zanchi, and together with Silvia Luraghi, I will be presenting HODEL, a new linguistic resource for the study of Homeric verbs. As you probably know, treelinks are text corpora with exhaustive syntactic annotation, typically applied on top of lemmatization, part-of-speech tagging, and morphological annotation. Currently, dependency tree banks, constituency tree banks for modern and ancient languages are online, and lately diachronic tree banks have also found room online, also integrated in the project Universal Dependencies. For our purposes today, tree banks for classical languages are particularly important. A very important one is the Index Domesticus tree bank for Latin, and the Ancient Greek and Latin Dependency Tree Bank, AGLDT 2.0, which I will be mentioning many times. Both are modeled on the Prague Dependency Tree Bank. Another family of tree banks, also dependency tree banks, but partly different, but with a partially different tag set, are the Proyal family tree banks. Some of these tree banks are supported by user-friendly interfaces where data is searchable without the usage of complex formalisms. For example, the Index Domesticus, valency Lexicon, Valex, as well as the Proyal web applications. We went exactly in this direction while building the Homeric Greek dependency lexicon HODEL, which is a new resource for the study of Homeric verbs together with their dependents and based on AGLDT 2.0. HODEL is a collection of all Homeric verbal forms enriched with their dependents that are supposed to be part of verbal valency according to the guidelines of the AGLDT. HODEL is modeled on the Index Domesticus Valency Lexicon, Valex, created at Circe by Marco Passarotti. It was planned to be a valency lexicon, but it turned out to be a dependency lexicon, as I will be explaining soon. The lexicon is already online at the link you can see on the slide, and I promise that the nice-looking homepage will be added soon. HODEL is one of the outcomes of the project Transitivity and Argument Structure in Flux, funded by the Italian Ministry of Education and Research and coordinated by Michela Cennamo and Silvia Luraghi. Paolo Ruffolo and I are the main responsible for its creation, but many other people also contributed to it in various ways and at different times, always under Silvia Luraghi's supervision. An earlier version of HODEL was released in 2016 and was based on a previous version of the dependency tree bank of Ancient Greek. So I will explain how we built HODEL, hinting at some technical as well as theoretical issues, whereas Silvia will later explain how to use HODEL together with its incorporated queries and filters, and she will also hint at some practical issues a user may encounter while using the resource. And she will also draw some conclusions. HODEL is a corpus-driven lexicon automatically induced from the analytical or syntactic annotation layer of the AGLDT 2.0. The latter is a dependency tree bank modeled, as I said, on the Prague dependency tree bank. In a nutshell, dependency tree banks are predicate-centered. They comprise syntactic trees with more than 2 branches. In those tree banks, the number of nodes corresponds to the number of words, and the annotation is structured as stored in different layers, namely the morphological, the analytical or syntactic, the techogrammatical or semantic ones. So this is the beginning of the Iliad in the Greek script. In this slide, you find the same passage, but transliterated and glossed. And finally here, you find the tree corresponding to this passage. So you find at the very top a root node from which a coordination node departs, because the beginning of the Iliad, the first sentence of the Iliad comprises 2 coordinated clauses. And as I said, the tree bank is predicate-centered, and so you first find the 2 coordinated verbs. tagged as predicate, coordinated, here and here. We extracted all Homeric finite and non-finite verb forms, along with their dependents that, according to the guidelines, are supposed to be part of verbal valency. So we extracted subjects, object complements as happy in Luke makes Claire happy, predicate nominals as happy in Luke is happy, and objects. Objects include accusative, dative, genitive nouns or pronouns, prepositional phrases, infinitive verbs, accusative plus infinitive constructions, relative clauses, and other types of subordinate clauses. So it's a very wide label, so to say. We did not extract, instead, dependents that were certainly not included in the verbal valency: adverbials, attributes, so modifiers of nominal phrases, and ATD, which are non-governed complements. That is, those predicative noun phrases or adjectives which may morphologically agree with their head noun, but qualify the event as a whole. The extracted dependents could be directly or indirectly linked to verbs. In case they were indirectly linked, they are attached to the verbal head via one of the so-called bridge nodes, which include prepositions, aux-P, conjunctions, aux-C, coordinators, coord, and opposing elements, apos. Here you find two subtrees containing bridge nodes, and on the right side of the slide you find two bridge nodes in a sequence. So you can see a preposition, dia, and two coordinated child nodes of that preposition. And those objects, coordinated objects, are taken by a coord node chi. And the supposedly argumental dependents have been extracted using a series of SQL queries. Extracted data is then recorded in a spreadsheet, which works as a backend for users' interface. The original query algorithm and its implementation have been conceived to build the valency lexicon of Thomas Aquinas' texts. And when we built HODEL, such queries have been adapted to the AGLDT tag set. Okay, now let's move on and talk about some theoretical issues behind HODEL, or the reasons why HODEL and similarly built lexica are not valency lexica. HODEL, as I said, is corpus-driven, but only in the sense that it was automatically induced from a corpus, not in the sense that it is theory-free. Because annotation schemas cannot be theory-free. Indeed, a proper source theory is essential to any annotation schema, as it contributes to reaching the desiderata for annotation, namely accuracy, consistency, and sustainable workflow. And problems may arise, and indeed arose in our case, when there is no acceptable degree of compatibility between the theoretical framework followed by the annotators and the one required by linguistic analysis. So we realized while building the research that our theory of valency is different from the theory of valency behind the AGLDT and the PDT as well. Very briefly, the theory of valency behind the AGLDT is the theory of valency of the functional generative description, where complementations can be divided into inner participants versus free modifications, and complementations can be obligatory versus optional. So the two classifications do not overlap. A key notion of this theory of valency, but maybe of any theory of valency, is the notion of obligatoriness. But despite its central role, this notion is not quite dealt with in the AGLDT guidelines. And that brings some unwelcome consequences. Here you find some examples of mismatch, passive agents. Mismatches coming directly from the aforementioned notion of obligatoriness, and I will discuss briefly beneficiary and instrumental datives, referential null arguments, and p-noms. Passive agents. Passive agents are annotated as objects, but passive voice is generally acknowledged as a valency decreasing strategy, which removes agents from argument structure. Here you find one such example where by Zeus, ekdios is tagged as object, so as part of the argument structure of the verb. Here you find a couple of examples where you can see that beneficiary and instrumental, beneficiary in this case actually an instrumental dative is tagged in two different ways, as obj and as adv, despite occurring in the very same context. So in 1 and 2 you find ophthalmoisi, the same prepositionless dative, into similar contexts and tagged in two different ways. So as part of the argument structure in 1 and as not part of the argument structure in 2. As for referential null arguments, as I remember at the beginning, AGLDT does not comprise any empty nodes at the analytical layer, which is completely normal because the ancient Greek and Latin dependency tree bank is structured according to the Prague dependency tree bank, where null arguments are supposed to be integrated at the tectogrammatical layer, not at the analytical layer. This, however, is highly problematic to study the valency of ancient Greek, as ancient Greek is a proto language where pronominal subjects are omitted by default. So not having a way to extract null referential subjects has the unwelcome consequence of treating in the same way, for example, zero-valent impersonal verbs, such as rain, and mono-valent verbs with omitted subjects. On top of this already very big issue, there are also null referential objects, which are obligatorily omitted under certain syntactic and pragmatic conditions in ancient Greek, as well as in other ancient Indo-European languages. So to summarize, both types of null arguments are frequent in ancient Greek. Both fill in slots of the verbal valency, and the fact that they are not annotated results in an incomplete account of the valency for specific verbs. Pinoms. The label pinom is used inconsistently. So theoretically, in a sentence like "Luke is in the kitchen," Luke is a prepositional phrase taken by a to be verb, which, however, functions as an existential locative verb. And in similar cases, prepositional phrases should be tagged as obj, not as pinom. But in similar sentences, such as that you find in 2, you find that the prepositional phrase, in this case, ein agorei, is tagged as pinom, as you can see from the tree we reported in the slide. Okay, I now leave the stage to Silvia Luraghi.
Thank you, Chiara. Now let's see what you can do with HODEL and who can use HODEL. So with HODEL, you can query the Homeric text starting either with a verb entry or with a dependent, and exploit the user-friendly interface and its incorporated filters that I'm going to show you now. Who can find it useful? Historical linguists, computational linguists, philologists, classical scholars, students of ancient Greek and linguistics, high school students, teachers of ancient Greek. HODEL provides transliteration of the Greek script and translation of the Greek passages into English, and for this reason, it can be used by linguists who are not Greek specialists and have no in-depth knowledge of ancient Greek. This is what you find when you start looking for a verb lemma in HODEL. You can look up for the verb by either clicking on it or using the query box that you see on your left. Here is what you find when you try to start a query with a specific lemma, with a specific dependent lemma. And this is what you get after a query with a verb. This is a query for the verb akuo here. and you can see that you can get the text as iterated. You see all occurrences of the verb along with its dependents. And this is the beta code you use to enter the Greek words. This is a query for AGO, as you can see in the query box, spelled in beta code. And here you get the results in Greek script, but as you have seen in the preceding slides, you can also get them transliterated. And this is the morphological information you get for verb lemmas, for example. You get the voice, mood, tense, and number information just by clicking on them. Here is a text with its translation. The translations have been automatically aligned from the Greek text stored in the Perseus library, but then we have them check them also manually, because the chunks are not always, chunking is not always correct. So now you get the correct translation and not a different chunk of English text. These are more complex queries you can perform. You can look up for specific types of dependents and for the number of arguments you want to find with a verb. You can also look up for sequences of dependents, and you can choose the order and the type of dependents that you want to find co-occurring with a certain verb. And you can look up for either syntactic relation of the dependents or case of the dependents, or mood if they are verbal dependents. Summing up, you can search for dependents with specific morphological or syntactic features associated with them. And you can search for multiple dependents at once, and for an exact number or an exact string of dependent, linear string of dependents. We inherited a number of errors contained in the ancient Greek dependency tree bank, and we are trying to fix some of them. We are working on this. In the first place, voice information is sometimes missing. This has already been manually corrected, and we have forwarded the file with our corrections to the developers of the ancient Greek dependency tree bank, and hopefully they will incorporate soon the missing information into the tree bank. Then there are some problems with the syntactic parsing in the tree bank. So some dependents are tagged as objects and they are adds. Some phrases are tagged as dependents and they are adverbials. For example, here in one, nukta diorphaneien. So Pallas Athena sent them a heron on the right next to the road, and they did not see it with their eyes in the dark night, but heard it crying. In the dark night is obviously a dependent, but it's tagged as an object in the tree bank. And another problem is that the enclitic adlative particle de is sometimes incorrectly lemmatized as the discourse particle de in the text inside the Perseus library. This has partly already been fixed in the Perseus project. Then another problem is lemmatization of verbs with suppletive stems. They are sometimes lemmatized under different entries. For example, the verb horao has 3 stems, hor, op, and eit, and it's lemmatized under 2 entries, one with the stems hop and hor, and one with the stem eit. But this is a problem. This is that the tree bank or the Perseus library inherited from the Liddell Scott Greek English Dictionary. And it brings about some inconsistencies because then prefix verb like eizorao are lemmatized as a single entry, even though eizorao also features 3 stems. Preverbs in basis position are perhaps the most difficult problem to fix in a tree bank. Preverbs in basis positions are verbal prefixes that are separated from the verb, and this is typical of the Homeric language. Here you can see they kept watch during the night because they were turning to the plain to see whether the Trojans were coming on. Coming on is a P onton, and the prefix P is separated from the verb by two constituents. But as you can see, it is not analyzed as a single entry with the verb, but as a separate adverb in the tree bank. So, to conclude, building HODEL has allowed us to reconsider some important methodological issues with respect to the theory and practice of textual syntactic annotation, and especially on the creation of new resources based on the exploitation of existing resources. And our conclusion is that great caution is needed because the annotation is never theory-free, and the metalinguistic information results from theoretical and practical choices made by the developers of the resource on which you base your new resource. HODEL is now online, and we are working to improve it. Even if some issues remain, we think that HODEL is a useful resource for the study of verb argument structure in ancient Greek, and in Homeric Greek in particular, and word order. And because it provides transliteration of the Greek script and translation of the Greek passages into English, it can be usable. It is usable also for non-specialists and people who basically don't know Greek. It has a very user-friendly interface and contains extremely rich data. And thank you very much for your attention.